The biggest solar storm in 20 years has hit Earth, but we've been fortunate so far. Despite this good news, astronomers remain on high alert. The most violent solar cycle in a long time isn't over, and a gigantic sunspot has formed, similar to the one that caused a catastrophic event in the USA 200 years ago. If this spot continues to grow, it could lead to colorful auroras or potentially paralyze all communication and power grids within minutes. Elon Musk expressed concern about the impact on his Starlink satellites, posting an alarming graphic on May 11, 2024, showing the pressure the last solar storm placed on his system. Musk's satellites were stretched to their limits by the violent stream of particles from the sun. While the protection mechanisms held this time, a more intense storm could overwhelm or destroy the technology. The consequences would be disastrous, not only causing regional internet and mobile networks to fail but also leading to the creation of space junk from damaged satellites. Musk acknowledged that they've been lucky this time, but his team remains on edge as they test the limits of their space marvels against solar storms, an often underestimated danger of the 21st century. Solar storms, while producing beautiful auroras, also pose serious risks. These streams of charged particles from the sun are captured by Earth's magnetic field, usually preventing them from penetrating deeper into the atmosphere. The northern and southern lights are a result of this interaction, and the recent storm caused auroras to be visible much further south than usual. However, scientists warn that more storms are on the way, and we may experience either stunning light shows or severe disruptions to our power grids and satellites. The current solar cycle, which peaks every 11 years, is proving to be exceptionally violent. Sunspots like the one dubbed AR 3664 are at the center of the storm's intensity. This sunspot group, visible from Earth in early May 2024, is 15 times the size of our planet and has been responsible for a significant number of solar flares. These flares, especially the X-class flares, release vast amounts of particles that can reach Earth within minutes, putting our technological infrastructure at risk. The unpredictability of these solar cycles makes it difficult for experts to prepare for the worst-case scenario. The solar maximum, a period of heightened activity, has arrived earlier than expected, leading to concerns that the sun's magnetic fields might be reversing, potentially causing even more frequent and intense geomagnetic storms. The last solar storms of this magnitude, known as the Halloween storms of 2003, caused widespread disruptions and were visible in unexpected regions such as Florida and Mexico. While AR 3664 is currently pointing away from Earth, providing some relief, it will soon rotate back into a position that could send more storms our way. As the sunspot continues to grow, the potential for another season of geomagnetic storms looms, and the world's astronomers are keeping a close watch on its activity. The sunspot's formation and growth have been tied to past events, including the infamous Carrington event of 1859, the most powerful solar storm in modern history. The Carrington event serves as a stark reminder of the destructive potential of solar storms. During this event, people across the world witnessed auroras as far south as Cuba and Hawaii, while the USA saw telegraph poles catch fire from the intense electromagnetic activity. Telegraph systems were severely disrupted, sparking fires and running without power as the storm's energy charged the wires. The technology of the 19th century may have been relatively primitive, but the damage caused by a similar event today would be catastrophic, given our reliance on satellites, power grids, and GPS systems. Solar storms are a constant, natural occurrence due to the sun's intense magnetic activity. These storms release energy in the form of solar flares and coronal mass ejections, CMEs, which travel through space and sometimes reach Earth. Solar flares are bright eruptions of energy, while CMEs consist of clouds of magnetized plasma that can take hours or days to reach our planet. In 1859, the Carrington event CME was so powerful that it reached Earth in just 20 minutes, an exceptional occurrence that scientists warn could happen again at any time. Despite their risks, solar storms play a vital role in the cosmic balance. They shape space weather, carry energy through the solar system, and contribute to the formation of Earth's heliosphere, a protective bubble that shields us from interstellar cosmic rays. Without the constant flow of charged particles from the Sun, life on Earth might not be possible. However, as our dependence on technology grows, so too does our vulnerability to these storms. Modern satellites are designed to withstand space weather, but not all technology is up to date. Governments and companies are working to make power grids, satellites, and communication networks more resilient, but outdated infrastructure remains a concern. A geomagnetic storm like the one that hit Canada in 1989 could paralyze regions for days, causing widespread outages. As satellite technology evolves, so too must our defenses against solar storms. The International Space Station, ISS, and spacecraft that supply it are particularly vulnerable to solar storms. High-energy particles can damage their electronic components, leading to malfunctions that could be life-threatening. This is why NASA and Musk's SpaceX are on high alert whenever a solar flare or CME is detected. Solar storms have become a pressing issue in the space age, where we rely heavily on technology that is vulnerable to geomagnetic disruptions. One of the greatest concerns is the impact these storms could have on the global power grid. In the event of a massive storm, power outages could cascade across continents, plunging millions into darkness. This would not only affect households and businesses but also critical services like hospitals, transportation, and water supplies. Restoring power after such an event could take weeks, if not months, depending on the extent of the damage. The economic fallout could be unprecedented, with losses running into trillions of dollars. In space, the danger is even more immediate. Satellites, which serve everything from GPS navigation to weather forecasting, are particularly susceptible to solar storms. High-energy particles can damage their delicate electronics, causing malfunctions or total failures. Even minor disruptions in satellite operations could lead to widespread chaos on Earth, affecting everything from airline traffic to financial markets. This is why space agencies and private companies like SpaceX have developed shielding and protective systems to guard their satellites, though these defenses have limits, especially against more violent storms like those generated by sunspot groups such as AR 3664. As solar activity intensifies, it is not just technology that faces challenges, human health could also be at risk. Astronauts aboard the International Space Station, or on future missions to the Moon and Mars, are particularly vulnerable to solar radiation. While Earth's atmosphere and magnetic field protect those on the ground, space travelers are exposed to much higher levels of radiation during solar flares and CMEs. A powerful storm could increase their risk of radiation sickness or long-term health effects like cancer. For this reason, space agencies must carefully monitor solar activity and adjust mission schedules or provide additional shielding during periods of intense storms. Historically, solar storms have occurred without warning, leaving little time for preparation. The Carrington event in 1859 remains the most extreme example of this, but it was not an isolated incident. Similar storms have struck Earth in the centuries since, and though they have caused less damage, the potential for a catastrophic event remains high. The Halloween storms of 2003 demonstrated how vulnerable modern technology is to space weather, causing widespread disruption and costing billions in damages. With the current solar maximum showing signs of increased volatility, scientists are urging governments to invest in better infrastructure and response strategies. The question of whether we can fully protect ourselves from the next big solar storm is still unanswered. While advancements in satellite technology and power grid resilience are promising, much of the world's infrastructure remains outdated and ill-prepared for a storm of Carrington-level intensity. The unpredictability of these events makes it difficult to develop foolproof defense mechanisms. However, increased awareness, continued research, and investment in new technologies could mitigate the worst impacts. As we move deeper into the space age, preparing for the next major solar storm is not just a precaution, it is a necessity. Ultimately, the threat posed by solar storms is not a matter of if, but when. While the stunning auroras they produce captivate us, the underlying risks to our technology, economy, and even human life demand serious attention. As we become increasingly dependent on satellites, power grids, and digital infrastructure, the need for improved protective measures against space weather grows ever more critical. The lessons of past storms like the Carrington event serve as a stark warning of what could happen again, and the current solar cycle suggests that we may face these challenges sooner rather than later. Being prepared for the next major solar storm is crucial to safeguarding our modern way of life. And there you have it. While the beauty of solar storms can light up our skies, their hidden power can disrupt life as we know it. As we head into an era of increased solar activity, it's more important than ever to stay prepared and protect our technology. Thanks for watching, and as always, stay curious and stay safe.